Okay, welcome class to another episode of Heat Energy. We're looking at calorimetry. Calorimetry, as we said in our previous class, is an experimental technique that is used for the quantitative measurement of heat exchange. So calorimetry deals with what? Heat exchange, but in quantity formats. That is, the mass must be measured because we're talking about quantity. To make such measurement, a calorimeter is used. One important use of calorimeter is to determine the specific heat capacity of a substance. So the use is what? To determine specific heat capacity of a substance. That's what we use calorimeter to do. And now, in order to do so, we are going to look at two methods. The first one is methods of mixtures, where we mix two liquids, and then we're going to find out a liquid or a solid, or liquid and liquid, to find out what the specific heat capacity is by how much degree it rises. And the next one we can also look at, next method is electrical method. Electrical method. In this case, we'll be looking at heater, where we get the energy from the heater and then it's transferred into whatever substance the case may be. So there are two methods we're going to use to determine the specific heat capacity. Remember, calorimeter is used to determine the specific heat capacity. So the principle that we're going to use to deal with this set of questions is what? Heat loss. Heat loss will be equal to heat gained. So that if I have a substance of boiling water, all right, and then maybe it's at 100 degrees Celsius, and I'm going to pour it in another substance that is cold at 20 degrees Celsius. This one is going to lose heat. So this will lose because it's going to experience a loss in its heat because it is more and they are mixing it at a lesser temperature. Whereas this one is going to do what? Gain. This will lose, this will gain. And of course, when they mix, maybe their mixture is what? At um 70 degrees Celsius. That's the maybe this is the mixture. So in this situation now, how we deal with these kinds of method of mixtures is we find the value of the heat loss and we equate it to the value of the heat gained. Whichever the case may be, then you'll be able to catch up. Now let's take some examples as we have on our right hand side. I'm sure you understood the explanation. If you don't understand, comment on this in the comment section and then let us know where you're having issues. Number one says a quantity of hot water at 100 degrees Celsius is added to 400 gram of water at 10 degrees Celsius. So they have two water here now. One is what? Hot water. One is hot, the other one is cold. And of course, there's going to be a mixture. So the hot water is at what? 100 degrees Celsius. That's the temperature. They now told you that it's added to 400 gram of what? 400 gram of water at 10 degrees Celsius. So the cold is what? 10 degrees Celsius. But this cold water has a mass 400 gram. So you add 100 degrees Celsius of water to a particular water that has a mass of 400 gram until the temperature of the mixture is 60 degrees. So the mixture is 60 degrees Celsius. Good. Calculate the mass of the hot water added. So what we are looking for now is the mass of this hot water that was added there. Calculate the mass of the hot water added. Specific heat capacity of the water is 4200. So whichever the case, the specific heat capacity is 4200 joules per kilogram per Kelvin. So this is for the cold water and for the hot water because it's still about what? Water, sorry. Look at the unit of specific capacity and the mass. This is in gram, this is in per kilogram. So we must convert this 400 gram. It gives us 0.4 kilograms. So like we said, heat loss is equal to heat gain. Heat loss. Who is losing heat? The hot water. So your MC change in theta, that's your quantity of heat. Your MC change in theta, that's also the formula for quantity of heat. So in this case, we'll be looking at for the hot water, for the hot, but this will be looking at for the cold because cold is the one gaining heat. The mass of the hot is unknown. The specific heat capacity of the water is 4200. The change in temperature, now this is where you must be very careful. This hot water is going to change temperature from what 100 to what 60 because after mixture it becomes 60. Cold after mixture it becomes 60. So the change in temperature is between is from 100 to 60, and if it's from 100 to 60, to find the change is what bigger minus smaller, 100 minus 60. Then for the right hand side, the cold water, the mass of the cold water is what 0.4, and specific heat capacity 4200 times your change in temperature. What will be your change in temperature? Your cold water is changing from 10 degrees Celsius to 60 degrees Celsius. It's increasing in temperature, so that is increase of 50, which is 60 minus 10. Please take note, is the bigger quantity, bigger temperature minus the smaller temperature. When we go on from here, we have M times 4200 times 40 equal to 0.4 times 4200 times 50. So let's multiply everything on the right hand side, and we're going to get multiply everything on the right hand side. You have 0.4 times 4200 times 50. That gives us 84,000. Yeah. Then on the left hand side, 4200 times 40, 4200 times 40. That gives you 168,000 times M. So that is 168,000. M is what? 84,000. Divided by the coefficient of M, which is 168,000. M is 84,000 divided by 168,000. That gives you 0.5 kg. Why is it in kg? We already worked with kg. So in case you are given a WAEC question, this is not in the option, but what you have in the option is in gram. So you convert 0.5 kg. Remember, kilo stands for what? 1000. So kilo is 1000. So when you have 0.5 kg, it means 0.5 times 1000, which is 500 gram. So 0.5 kg is your answer. If you don't see this in the option, it means they put the answer in what gram, which you will convert it back to gram. You must understand your conversion rates so that you don't have issues in the exam hall. Next up is question number 2. A non-conducting vessel contains a liquid of mass 70 gram at 25 degree Celsius. So the particular vessel, let's say this is the vessel, it has a liquid which has a mass of what? 70 gram and a temperature of 25 degrees Celsius. Another 70 gram of the same liquid, so the same liquid now in this case is what? Another 70 gram of that same liquid at 35 degrees Celsius. Good. It's quickly poured into the vessel. So you're pouring this into this vessel. So you're mixing this one and this, you're mixing them. So when we mix, of course, we are going to have a fresh temperature of the mix. Is it given here? It's not given. So we are asked to find the final temperature of the mixture. So that's what we are looking for, the temperature of the mixture. When you mix this with this, if you notice they are the same liquid. So the same liquid simply means whether they are given, you are given the specific heat capacity or not, they are the same. So that if this were to be water, specific capacity of water 4,200, and this is the same liquid 4,200, so they are the same. Basically, they are going to cancel themselves out. But let's just write it as specific capacity as C, the same in both case. So our theory is what? Heat gain, heat loss is heat gained. Who is losing heat? Obviously, this is losing heat because this is 35 degrees Celsius. It's losing heat. When you pour it with a lower temperature, it's going to reduce, come down. So MC change in theta is equals to MC change in theta. Your mass of this guy is losing heat is 70. Specific capacity is C. Your change in temperature, this is the major aspect. If this is losing heat because it's 35, this is 25. When you mix a hot and a cold, the hot will lose, the cold will gain. If this is losing heat, it means the final mixture will be lesser. Final mixture will be less. It will drop down, which means this will be bigger than the final temperature. So 35 minus the mixture, because that is the change in temperature. It will change from 35 to a new mixture temperature. Who is gaining heat? This. The mass is what? 70 times specific heat capacity, which is C, times, when this gains, the mixture will be higher than this. The mixture theta will be higher than that. So it will be theta minus what? 25. Please don't forget this. Don't forget this. The bigger minus the smaller. 70C, they cancel themselves out. They divide themselves, is gone. So I have 35 minus theta equals to theta minus 25. If you are still confused how this can divide themselves, I'll show you shortly after this teaching. Now, collect like terms, theta is going to come here, and you have 35 minus theta equals to minus 25. Then 35 goes there, minus theta equal to minus 25 minus 35. Minus this gives me minus 2 theta, that is minus 60. Minus 60. So you divide by the coefficient, theta is equals to minus 60 over minus 2, which is 30 degree Celsius. So this is the mixture temperature of the whole arrangement. I want to believe you are following what we are doing. So that's the mixture. And then for those who are having issues with how this is going to be this, I'm going to show you shortly now, mathematically, how that is possible. You must understand that you must know maths very well to be able to deal with physics problem, because we are going to be applying mathematical rules. Now, in mathematics, in maths, a recap is that if we are dealing with equality sign or ratio or division, right? So if I have 18x equal to 36, or I have 18 ratio 18x ratio 36, or I have 18x divided by 36. When you have any of these symbols, this is the first, this is the second, this is the third, you can divide them the way they are. Ordinarily, we know that if I have 18 over 36, I should be able to divide like this. But if it is written as 18 ratio 36, notice ratio is division in mathematics. So it's the same thing. The same thing. But then here's where many people get confused. When it's equal to, yes, the same thing. You can also divide. So that 18 here is 1, 18 here is 2. Therefore, x equal to 2. That's the arrangement. T. Hot water, question 3. Hot water at temperature T. So that's the temperature of the hot water. Temperature T is added to twice is added to twice that amount of water. That amount of water. Which water? This particular water that is hot. We add hot water is added to twice this amount of water. So the original water, the size, hot water is added to it to twice of the original water. Go on. It says at a temperature of 30 degrees Celsius. At a temperature of 30 degrees Celsius. Question. If the resulting temperature of the mixture, so if mixture is is 50 degrees Celsius, if mixture is 50 degrees Celsius, I'm trying to write the question and read it so it will go resonate over your head. Then you can pause the video and try to solve it before I go on to solve. Calculate T. What is the T? The temperature T there. Let's work this out. Hot water and another water, which will be cold, because you say hot water is at a particular temperature. We don't know the temperature, but we know it's hot. You add it to twice that amount of water. The size of the water before, you add it to twice of that size. The 30 degree calorimetry is very, very important topic. It will come out in your exam always. Thank you.